Hello students, today we will discuss the topic 4-bar kinematic chain. So a 4-bar kinematic linkage, which is also called as a 4-bar, is the simplest movable closed chain linkage. So a 4-bar linkage, also called as 4-bar, is the simplest movable closed chain linkage. So 4-bar means there are 4 elements. So this is the first, second, third and fourth. So there are 4 elements which are movable and they form a closed linkage. So you can see there is a closed loop formed here. So this is called as a closed chain linkage. So it consists of 4 bodies, or we can call them as bars or linkages. So it consists of 4 bodies called as bars or links. We can call them as, so this is one link, this is the second link, this is the third link and this is the fourth link. So these links are connected in a loop by 4 joints. So they are connected in a loop by 4 joints. So this is first joint, this is the second joint, this is the third joint and this is the fourth joint. So they are connected by 4 joints. So generally these joints are configured so that the links move in parallel planes. So the joints are configured so the links move in parallel planes. And the assembly is called as a planar 4-bar linkage. The assembly is called as the planar. So this assembly of the 4 linkages, it is called as a planar 4-bar linkage. So among this, we will study about the inversion of 4-bar chain. So what is inversion? Inversion of 4-bar chain. So the first inversion or the first mechanism which we are going to study is the crank rocker mechanism. So while studying the mechanism, we have studied about the inversion. Inversion is nothing but if there are 4 linkages, if we are fixing the linkages turn by turn. So first we will fix the first link, then one type of mechanism will be formed. If the second link is fixed, then there will be a different type of mechanism formed. So for 4 different types of linkages, when we fix them turn by turn, there are different mechanisms formed each time. So here we are going to study about crank and rocker mechanism. Here we can see the figure which is showing the crank and rocker mechanism. So in this case, for every complete rotation of link 2, so this is link 2. So for every complete rotation of this link, so you can see this link is rotating and forming a circle. This link 2 is called as the crank. So for every complete rotation of this link 2, the link 4, that is this link 4, which is called as the lever, and this is called as the link 2 is called as the crank. So this link 2, when it is rotating, the link 4 makes oscillation between the extreme points, that is O4 B1. So here this is O4 and this is B1. So when the crank is rotating, this lever, or it is also called as rocker. So that is why the name crank and rocker mechanism. Okay. When this crank rotates, this rocker will oscillate between the extreme points, that is O4 B1. So this is B1 and O4 B2. So in this case, for every complete rotation of link 2, which is called as crank, the link 4 called as lever or rocker makes oscillation between extreme positions, that is O4 B1 and O4 B2. Okay. Then the position of O4 B1 is obtained when the point A is at A1. So this position, so you can see this position of O4 B1. This is O4 and this is B1. So this position of the lever is obtained. So this position O4 B1 is obtained when this A, that is this crank position, is at A1. So this is A1. So when the crank is at A1, we will obtain the rocker position at O4 B1. So we have studied what is a 4-bar kinematic chain. Now we will look into the inversions of 4-bar chain. So inversion of 4-bar chain. So there are different mechanisms formed by the inversions of this 4-bar chain. The first mechanism which we will study is the crank rocker mechanism. So this mechanism is shown in the figure here. So this is a crank and rocker mechanism. So in this case, for every complete rotation of link 2, so here this is link 2, okay, O2A is the link 2, okay. So this link 2, when it rotates completely, then the link 4, so this is the link 4, okay, this link is called as link 4, that is O4B. Okay, it makes oscillation between the extreme points O4 B1. So this is O4 and this is B1. So when this link 2 makes one complete rotation, this link 4 makes oscillation between extreme points O4 B1 and O4 B2. Okay, so it will oscillate in this direction for one complete rotation of link 2. So link 2 here is the crank and link 4 is the rocker. So that is why it is named as the crank and rocker mechanism, or rocker can also be called as lever. Crank and lever mechanism also it can be called. So in this case, for every complete rotation of link 2, which is called as crank, so link 2 is the crank, the link 4, which is called as lever or rocker, makes oscillation, that is it oscillates between the extreme points, extreme positions O2, B1 and O4 B1 and O4 B2. Okay, then the position of O4 B1 is obtained when A is at A1. So this rocker comes to this position, that is O4 B1, when this A is at A1 position. So we know that this crank is rotating. Okay, when it reaches A1 position, then the rocker will be in the O4 B1 position. So the position of O4 B1 is obtained when point A is A1 and the position O4 B2, that is O4 and B2, this position is obtained when A is at A2. So when this A is at the position A2, then this rocker or lever is at position O4 B2. The position of O4 B2 is obtained when point A is A2. Okay. So we can observe that the crank angles for the two strokes, that is forward and backward, of oscillating link O4B are not same. So when A is at A1, then the rocker is at O4 B1. So here the angle is a little less. But when you see that for the next extreme position of the rocker, that is O4 B2, the angle which the crank has to rotate is a bit larger, that is A2 A2. Okay, so this we are observing, that is the crank angles. So it may be observed that crank angles for the two strokes of oscillating link O4B are not same. And we may also note that the length of the crank is very short. So when you see, the rocker is a bit larger than the crank. So the length of crank is very short. So this is about the crank and lever mechanism. The next type of mechanism is the double lever mechanism, or it can be also called as rocker mechanism. Here there is no crank observed here. There are two rockers instead. So it is called as double lever, that is double rocker mechanism or double lever mechanism. So in this mechanism, both the links 2 and 4 can only oscillate. So here there is no rotation at all. So there are two rockers, that is link 2 and link 4. Both of them are oscillating, they are not rotating. So in this mechanism, both the links 2 and 4 are only oscillating. So link O2A, so this is O2 and this is A. So this link O2A oscillates between position O2A1, okay, between these positions O2A1 and O2A2. So this is O2A2. So this link or this rocker is oscillating between O2A1 and O2A2. The link O2A oscillates between positions O2A1 and O2A2. Whereas the link O4B, so this is O4, this is O4 and this is B. So this link O4B oscillates between position O4A1, O4B1, that is here, this is B1. So O4B1 and O4B2. So this is B2. So it is oscillating in between O4B1 and O4B2. O4B oscillates between positions O4B1 and O4B2. So position O4B2 is obtained. So this position O4B2 is obtained when O2A and AB are along straight line. So if you want to obtain this position O4B, you have to see that this is AB, okay? This is A and this is B. So you have to see that this position O2A and AB are along straight line. So when O2A, they are in a straight line position like this, then AB is also like this. Then you will obtain this position O4B2. So when they are along a straight line, then O4B2 is obtained. Position O4B2 is obtained when O2A and AB are along straight line. The same way, position O2 A1, that is, this is O2 and this is A1. This position is obtained when O4B, that is, this is O4 and this is B, are along a straight line with AB. So when O4B and AB are in a straight line, then we will obtain this O2 A1 position. O2 A1 is obtained when AB and O4B are along straight line. So this is about the double lever mechanism. The next mechanism is the double crank mechanism, which is formed by the inversion of the 4-bar mechanism. So here link 2 and link 4 of the double crank mechanism make a complete revolution. So here both are cranks here, that is why it is named as double crank mechanism, and crank makes a complete revolution. The link 2 and 4 of this mechanism make complete revolutions. So in this mechanism, the length of link 2 and link 4 are equal. The length of link 2 and 4 are equal. The length of link 1 and 3 are equal. So this is link 1 here. Okay, so this is 1 and this is also 1. So the length of link 1 and link 3 are equal. The lengths of link 1 and 3 are equal. So the example where this double crank mechanism is coupling of locomotive wheels, where wheels act as cranks of equal length and the length of the coupling rod is equal to the center distance between the two coupled wheels. So the familiar example is coupling of the locomotive wheels, where wheels act as, so the coupling of locomotive wheels is the example of this double crank mechanism. Here the wheels act as cranks of equal length. So as I have told you, in double crank mechanism, the length of both the cranks will be equal. Then the length of the coupling rod, so link 1 and link 3, that is acting as the coupling rod in this example. The length of the coupling rod is equal to center distance. So let us consider the length of the coupling rod is link 3. Then this link 3, this coupling rod's length is equal to the center distance between the two coupled wheels. So let us consider this portion, that is this revolutionary part or the circle. Let us consider it as first wheel and this is the second wheel. Okay, so if link 3 is the length of the coupling rod, this length of coupling rod, that is length of the link 3, is equal to the center distance between the two coupled wheels. So here also we can see, if these are the two wheels, the distance between the center of these two coupled wheels will be equal to the distance or the length of the link 3. This is the meaning of the double crank mechanism. So this is all about the inversion of the double crank mechanism or 4-bar kinematic chain. I hope you have understood the topic. Thank you.